welcome. Today we're going to look at exponential decay. Just like in our previous lesson where we were talking about exponential growth and we saw numbers increasing very rapidly, we're going to be seeing numbers decrease very rapidly, and we're going to talk about how to take this information out of a table and write a rule. So the first thing that I want to do, let me get my pen ready here. I'm going to look at my values and I'm going to see how they're changing. What am I multiplying by to get to the next number? So here in the first one, I can see that I start at 24 and I go to 12. But what can I multiply 24 by to get to 12? Well, that would be times 1/2 or times 0.5. So if I could try that again to go from 12 to 6, again, I'd have to multiply by 1/2. From 6 to 3 times 1/2. Again, times 1/2 to 1/2, and finally to 0.75, which is the same as 3/4. So I can see each time from one level to the next, I'm multiplying by 1/2. Now, the other piece of information I need to write my rule is I need to look here and see when my x is 0, what's my y value? Because that's going to be the a value in my equation. So I would say y equals my initial value, which is 6, times 1/2 to the power of x. Awesome. Not too terrible. Let's take a look at another one. So again, here's my table. I'm going to start by looking at my values and say, what am I multiplying by each time? What's causing that change? And if I look here, it looks like I'm dividing by 3, which is the same as multiplying by 1/3. Now, usually I'll say, oh, you can write it as a decimal, but 1/3 is going to give you a more accurate value than multiplying by 0.3333 because it's a repeating decimal. So we're going to use 1/3. If I look here again at where my x is 0, I need that value. That's my initial value. So I would say y equals my initial value of 1 times 1/3 to the power of x. Now here's the thing, I can write that without that 1 in front of it because multiplying by 1 doesn't change anything, and I can just write that as 1/3 to the power of x. All right, one more example. This one's a little more challenging, but not too terrible. Again, I got to look at my y values, my output values, and say, okay, how is this thing changing? What's happening? I can see that it's being reduced, but I got to figure out how it's being reduced. And I don't know how to go from 27 to 18 or from 12 to 8. I don't know what I'm multiplying by that. So let me show you a shortcut. I can take two values that are next to each other. So I'm going to take 8 and 12. And I can write that as a division problem and say 8 divided by 12. Since I'm trying to see what I'm multiplying the first thing by to get to the second, then I would take the second divided by the first. And if I simplify that, I can divide both of those by 4 and I get 2/3. So that is going to be the value that I'm multiplying each one by. And I'm going to check it as I go through. So times 2/3. Well, let's see. 27 times 2 is 54. 54 divided by 3 is 18. Oh, okay. Well, let's try this next one from 18 to 12. So 18 times 2 is 36. 36 divided by 3 is 12. All right, 12 times 2 is 24. Divided by 3 is 8. And then 8 times 2 is 16 divided by 3. And we even left that one as the fraction, 16/3. So I can take this information along with what is my value, my y value when my x is 0. That's going to be my initial value. I can put those two pieces together and write my equation. So y equals 27 is my initial value times 2/3 to the power of x.